Albertian Institute of Science and Technology. Make engineers, not just engineering graduates.
Hello my dear students, I am Ringu John from the Department of Civil Engineering, Albertian Institute of Science and Technology. I welcome you all to this session on the topic Prestressed Concrete from the course CE 304 Design of Concrete Structures 2. Subjective of this session is to study about the prestressed concrete, material used for its construction, different prestressing methods. After the session, the students will be able to explain what is prestressed concrete, the various materials used for its construction and the different prestressing methods. So these all are the topics that I am going to take during the session. The first one is what is prestressing and what are the basic concepts of prestressed concrete, the various materials used in the prestressed concrete, and the advantages of PSC over RC structures, different prestressing methods, and at last the limitations of prestressed concrete. So coming to the introduction, what is prestressing? So before we start with the prestressed concrete, I shall explain the history behind this prestressing method. So as we all know, in a reinforced concrete structure, as shown in figure, they are well capable of taking all kind of compressive stresses. But it has so many drawbacks, such as it is very weak in tension and also it is brittle in nature. So while we design this RC reinforced concrete structures, two things are kept in mind. The first one is the ultimate strength and the second one is deflection. Before the failure of any structure, one thing is always common, that is none other than the development of cracks. There will be numerous cracks developed on the surface of the reinforced concrete structures, and the steel reinforcement that are kept inside the concrete structures got corroded when the cracks are exposed to the humid atmosphere conditions. So this steel reinforcement no longer take up any kind of tensile stresses, and as a result of this, that leads to the reduction of strength. Gradually, the collapse of the structure can be expected. So in order to avoid cracks, in order to increase strength and to reduce deflections, actually we are going for this prestressed concrete method or PSC. So now let's have a look on the basic concept of prestressed concrete. When we apply the vertical load on a concrete member, what actually happens is a deflection will be observed, especially at the midspan of the structure. That means the concrete will experience a sort of compression at the top and tension at the bottom. As you all know, the concrete can't take up so many tensile stresses at this portion, and that will result in the development of cracks. That's why we are providing the steel reinforcement or tendons at the bottom of the reinforced concrete structures. So what happens in prestressed concrete is this tendons will be get stressed by making use of tensioning devices, and these high tensile bars have the capacity to prevent cracking on the concrete. This is actually happening in the prestressed concrete structures. That is, in prestressed concrete, actually what is happening is tendons are stretched along the ends and the concrete is poured. After the concrete achieved required strength, we will release the tendons from its support conditions. So this make a transfer of prestress from the tendons to the concrete that is near to the RC member. So we will get a prestressed deflection as shown in this figure in the upward direction. So lot of compressive stresses will be obtained in this bottom portion and this will act in this direction. So what is actually happening is the stresses that is formed due to the service load, or otherwise we will call it as live load, will be counteracted with this compressive stress that is formed from the pre-stressing of tendons. So let's see the different materials used in pre-stressed concrete. The first one is the high tensile steel. As we all know, in reinforced concrete structure, ordinary mild steel and deformed bars are usually used, but they are not at all suitable in the case of pre-stressed concrete because of their lower yield stress value. So due to this lower yield stress value, we have to go for some other types of steel reinforcement. So here comes the different forms of high tensile steel. The first one is wires, second one is strand, the next one is tendons. So what is wires? They are structural elements that are having the diameter 7 mm, and when they combine together we will get strands, and again a collection of these strands that are bound together and engaged in a duct, we will get tendons. So the steel bars which are used in the pre-stressed concrete are usually having the diameter more than 20 mm. The another important material used in the pre-stressed concrete is high strength concrete itself. As per IS 1343, it recommends a minimum mix of M40 for the pre-tensioned and M30 for post-tensioned system. So what is the importance of this mix is that they are having high compressive strength and greater value of modulus of elasticity. Therefore, it leads to the least deflection in that structure. The use of high strength concrete results in the smaller sections, and also these sections will offer greater resistance against tension, shear and bearing. So now moving on to the advantages of pre-stressed concrete over reinforced concrete structures. The members that are obtained from PSC or pre-stressed concrete members are always thinner and lighter in cross section. Therefore, you can expect a least value for the self weight, and also we can ensure the overall economy of the project. The structure with this pre-stressed concrete will have a longer unsupported span, and also you can expect least deflections when compared to RC structure. And the another important thing is the concrete in the PSC, that is the pre-stressed concrete structures, will not get cracked easily, and therefore you can avoid all kind of steel rusting, and therefore thereby you can ensure the initial strength value. So that's why we are applying this pre-stressed concrete in the different fields like bridges, sleepers in railways, high-rise building floor system, and storage tanks, etc. So now we will have a look on the different pre-stressing methods. So there are mainly two types of pre-stressing method. The first one is pre-tensioning method and the second one is post-tensioning method. Coming to the pre-tensioning method, here the important feature is that pre-stress is induced before the concrete is placed. Here you can see a pre-stressing bed. At its two ends you have the end abutments where the tendons are supported, and you have a tensioning device that's called jack. And the first thing you are doing is you will stretch these tendons apart and are supported on the end abutment. Then we will apply all kind of tensioning by using jack-like devices. After that, the concrete is poured to this stretched tendons. Then we will wait for some days to get the concrete hardened. Once the concrete gets hardened, you will release or cut the tendons so that a transfer of pre-stress occurs in between tendons as well as the concrete. So this is actually happening in a pre-tensioning method. That is, first we have to apply tension to the tendons, then casting of the concrete, and at last the transferring of pre-stress. So basic features of this pre-tensioning method is, this is mostly done in factories, and then after that you will be transported it into the sites. So the main peculiar feature of this method is that it is more reliable and durable. And the drawback for this pre-tensioning method is it is only used for smaller sections, and for the heavier and longer sections it will be so difficult to pre-stress. That's why we are going to use this pre-tensioning method in the various fields of civil engineering like foundation pile, railway sleepers, lighting pole, floor slab, beam, pipe and partition walls. Now let's have a look on the post-tensioning method. In this method, pre-stress is induced only after the concrete has hardened. So in this figure you can see the green color tube. So this represents the tubes through which the tendons are placed later. So first of all the concrete is poured and are set to harden. Once it had achieved sufficient strength, the tendons are stressed using tensioning devices as it is shown in the figure. After the application of pre-stressing force, the tendons are cut and released slowly. So this will result in the transfer of pre-stress from the tendons to the nearby concrete. So this is actually happening in the post-tensioning method. Then the void spaces between the tendons and the duct are closed by making use of cement grout. So these are the features of post-tensioning method. So this method can be done in factories as well as in site. Loss of pre-stress is very less compared to the pre-tensioned concrete structure. The structure which are constructed using this method are always sleek and slender. So that will result in the least self-weight and consumption of the material can be reduced. The structure which are constructed using the post-tensioning method are widely adaptable in heavily loaded large span structures, and they are free from all kinds of cracks and are having high fire resistance. So in total you can summarize as the compressive strength of the concrete and the tensile strength of the steel are used at its fullest in the post-tensioning method. So it has numerous applications in the field of civil engineering, that is it is applied for roads, bridges, railways, tunnels, dams, containment tanks, underground structures, and it can be applied for all kinds of special structures. So even though it has lot of merits, there are few limitations also. The pre-stressed concrete structure requires very good quality control and also supervision. The cost of the materials used in the pre-stressed concrete is very high. The tensioning equipment and devices are very expensive, and also this method needs skilled laborers and greater supervision. Therefore, it is uneconomical for the structures with very short span and light loads. To summarize, we have discussed what is pre-stressing, the different materials used for its construction, advantages of pre-stressed concrete over reinforced concrete structure, pre-stressing methods, and the various limitations of pre-stressed concrete. Hope you have understood the session. Thanks for watching.